Hi everyone, we are beginning our second section of Chapter 7. Our chapter is all about sampling distributions. We learned in the first section what the basics of a sampling distribution are. This section is going to focus on proportions, and the next one will focus on means. By the end of this lesson, you should be able to find both the mean and the standard deviation of a sampling distribution of a sample proportion. It's a mouthful. We're going to determine whether or not we can use normal approximation. Then we're going to be able to calculate those probabilities involving sample proportions, and then evaluate claims. That can probably be the most tricky. There's going to be an in-class activity that we will talk about in class, so we're just going to skip over this part real quick. We're going to talk about our symbols, what they mean, okay? So I would pause this and copy down what each symbol is. There is a difference between mu and mu sub p hat. There's a difference between sigma and sigma sub p hat, right? This is a population mean. This is a mean of the sampling distribution of the sample proportions, right? P hat is sample proportions. So it's the mean of the sample proportions. Very tricky to understand, but notation here is so crucial, everyone. So crucial. All right. If I could have a highlighter, I would highlight this entire whole box. This is the meat and potatoes of what you need to know. So important about a sampling distribution of a sample proportion. So, if we were to choose a simple random sample of size n from some population and with some proportion of successes p hat is going to be my sample proportion. Then, here are my formulas. This is important. The mean of the sampling distribution is equal to the population proportion. The mean of the sampling distribution is equal to the population proportion. Okay? The standard deviation of the sampling distribution is given by this formula here. And it says as long as the 10% condition is satisfied. Now, what is the 10% condition? In the first section, I told you it was very important that your population couldn't be more, or had to be more, than 10% of your sample. I didn't say that right. Your sample can't be bigger than 10% of your population. There you go. All right, so that's that condition there. Yes, your sample has to be less than 10% of your population. Also, we can use normal techniques as long as these two calculations are true. So something else we have to check besides the 10% condition. We have to check that the sample size times the population proportion is greater than or equal to 10, and that the sample size times the complement of that is also greater than or equal to 10. So some conditions that have to be true when we're trying to solve problems here. So, quick recap. These formulas. If I were you, I'd locate these on your formula sheet. Make sure you know where they are and what they mean. And again, here's that 10% condition. Sample size must be less than 10% of the total population. So, let's talk about those conditions real quick. In the game of Scrabble, each player starts by drawing 7 tiles from a bag of 100 tiles. There are 42 vowels, 56 consonants, and 2 blank tiles. Kate chooses a simple random sample of 7 tiles. Let p hat be the proportion of vowels in her sample. So, this is one of those rare cases where we actually know the population size. Population size here is 100. Sample size here is 7. Is the 10% condition met? Is the 10% condition met? Yes, it is. 7 is less than 10% of the population of 100 tiles. Okay? Is the normal condition met? So going back, we have to check these two calculations to see if it is approximately a normal distribution. So, the sample size is 7. N times p and n times 1 minus p must be less than 10. Right? They have to be less than, wait. Okay, so I think I got cut off, but that's okay. Is the normal condition met? Justify your answer. No, it's not. So since the total sample size was 7, right, that's our n, and my proportion of, what we're doing in this case, vowels, our proportion of vowels was 42 over 100, so 0.42. Showing your math, n times p gives us 2.94, n times 1 minus p gives us 4.06. They both need to be greater than or equal to 10, and unfortunately they are not, so therefore the normal condition is not satisfied. Okay? And we need to check these conditions every time when we do a problem in order to use normal techniques, right? So things that we learned back in previous chapters are coming back now. So here's an example. A polling organization asks a simple random sample of 1,500 first-year college students how far away their home is. Suppose that 35% of all first-year students actually attend college within 50 miles of home. What is the probability that the random sample of 1,500 students will give a result within 2 percentage points of this true value? We are going to follow a 4-step process here, folks, and we need to write out this 4-step process every single time on every single problem. Okay? So, step 1 is we have to state what is going on here, kind of just summarizing the problem. What do we want to do? We want to find the probability that the percentage of first-year college students who attend college within 50 miles is between 33% and 37%. Where did those numbers come from? I'll tell you. It said within 2 percentage points of the true value. The true value is 35. 35 minus 2 is 33. 35 plus 2 is 37. That's where those values came from. So, this is what we're trying to find. So, our plan. We have a simple random sample of size 1,500, okay, drawn from a population in which the proportion is actually 0.35. So, our mean of our sampling distribution of sample proportions is 0.35. That's how you read that, folks. The mean of the sampling distribution of sample proportions. Now, the standard deviation of the sampling distribution of sample proportions is given by this formula, which is on your formula sheet. You have P, 1 minus P, and then your sample size. And that's estimated here. Now, as part of the plan, we also need to check our conditions. We need to check our conditions, okay? So, 2 conditions here. The independent condition and the normality condition. So the independent thing is also called the 10% condition. So we took a sample of 1,500. It's reasonable to assume that there are more than 15,000 college freshmen. Therefore, the sample represents less than 10% of the population, which is what we want. You have to write that. It has to be stated. As far as normality, you have to show the calculations. N times P is 525. N times 1 minus P, 975, both of which are greater than 10, so it's reasonable for us to assume normality. So we've done state, we've done plan, now we do the math. We want to know between these 2 values. So we can use our calculator and do normal CDF. If you weren't a huge fan of normal CDF, you could do it the old school way and actually calculate the z-scores for each value. So I would have done, for example, 0.37 minus 0.35 divided by my standard deviation to get this z-score. Same thing for 0.33, get my z-scores here. Then I would look them up in my table, subtract the 2 values to find the value of the in-between. Okay, a picture does help too. So we get a value of 0.896. From the calculator. So, come to your conclusion. There is an 89.61% chance that the sample will yield results within 2 percentage points of the true value. Okay, let's do another one. All right, take a moment and read this to yourself. So, some things to note. We're saying that the population proportion is close to 0.67, okay? we want to find the probability that if I were to take a simple random sample of 100 students, what's the chance that it is as small or smaller than this particular sample? So, go through our steps. What do we want? We want to find the probability that our sample proportion is less than or equal to 0.62. 0.62. Where did 0.62 come from? Well, it says that they found that 62 out of the 100 support this, and we want to know as a result of that sample. So 0.62 is our goal here. So the mean, though, of our sampling distribution of sample proportions is 0.67. And here is our standard deviation of that sampling distribution. Go through my conditions. Reasonable to assume there are more than 1,000 college freshmen. Since we took a sample of 100, 10% of 1,000 is 100. So 10% condition has been satisfied. Going through the normality ones, we have 67 and 33. Both are greater than 10, so it's reasonable to assume normality. So, doing our calculation in our calculator, from 0 to 0.62. Why 0? Well, it's proportions. You can't have a proportion that's smaller than 0. So you can start at 0 there, and that's fine. Make sure you're including your labels. So what should I write above this? Min, max, mean, standard deviation. And when we do that, we get a value of 0.1438. That is your probability. That's your percentage. So write your conclusion statement. There is a 14.38% chance that the sample will yield results at or below 62%, given that the true population proportion is 67%. I actually should probably change this conclusion because it's not very good as far as including the context of the problem. I should have included a little bit more context there. So maybe let's change this to say there is a 14.3% chance that the sample will yield results. So what are our results here? That the true proportion that support a crackdown on underage drinking is at or below 62%. So include some kind of context in the problem. The wording doesn't need to be perfect, but it does need to include context. There is one more example on your notes having to do with middle school students. I want you to try this one on your own. Go through the 4-step process. You should clearly be able to see the state, the plan, the do, and the conclude. Okay? Now, if you are curious as to where these formulas came from, I will leave this here for your perusal. Back in Chapter 6, you learned about binomial random variables and how to find the mean and the standard deviation of those. And so, if you're interested in those formulas, do I need you to know this? No. But sometimes people are like, I wonder where that came from. This is where it came from. Okay? So, next class, I expect you to have that superintendent last example in your notes completed. And we will practice more from there. Thanks, guys. Have a good one.